Chapter 1, Chemical Reactions and Equations. Introduction. In lower classes, you have studied about various changes like temporary changes, permanent changes, natural changes, and man-made changes, etc., and categorized them as physical changes and chemical changes. In this chapter, we'll discuss about chemical changes, reactions in these changes, and expressing the reactions in symbolic form. We'll consider some of the events which are happening in our daily life and think about changes and reactions that are taking place during the occurrence of events. Coal is burnt, food gets digested in our body, iron nail is exposed to humid atmosphere for a long time, we respire, respiration process, milk is converted into curd, water is added to quicklime, crackers are burnt more at Diwali time. What changes do you notice? Are they physical changes or chemical changes? Are they temporary changes or permanent changes? In all above events, we observe that the nature of original substance is changed. Whenever new substances are formed with properties completely unlike those of original substances, we say a chemical change has taken place. How do we know a chemical reaction has taken place? Let us perform some activities to know this. Before going to details of activities, let us know objectives covered in this chapter. Here are the few basic concepts for your reference. The basic concepts involved in this chapter are change. Changes take place every moment around us, like melting of ice, the freezing of water, the digestion of food. Types of changes. Based on the formation of resultant. Reversible and irreversible changes based on the repetition of change with the time interval. Periodic and non-periodic changes. Reversible change. The change of ice into water and water into ice are reversible changes. A change is said to be irreversible when the change can be reversed by reversing the conditions. Irreversible change. A change is said to be reversible when the change can be reversed by reversing the conditions. Irreversible change. A change is said to be irreversible when the change cannot be reversed by reversing the conditions. Example: is any equation or event in our daily life like milk is curdled, a new substance is formed, we cannot get the milk from curd. Physical change. A change in which no new substances are formed which can be reversed by reversing the conditions is called physical change. Change of mass in a physical change. No matter mass is added during a physical change, similarly, no matter is removed during a physical change. Therefore, mass of substance remains same. Example: ice to water and water to ice, reversible. Physical change is temporary and reversible. Chemical change. A change in which new substances are formed and which cannot be reversed by reversing the conditions is called a chemical change. Chemical change is a permanent change. Change of mass in a chemical change. The mass of an individual substance undergoing a chemical change is altered. Example: if an iron nail is allowed to rust, the mass of rust nail is more than that of original nail. Objectives. Activity 1. Explanation of a change that changes state and color of substance and release heat energy. Activity 2. Explanation of a change which forms an insoluble substance as precipitate. Activity 3. explanation of a change that liberate gas. Chemical equations. Writing a chemical equation. Balancing chemical equations. Types of chemical reactions. Activity 4. Explanation about chemical combination reaction. Activity 5. Explanation about chemical decomposition reaction. Activity 6. About chemical decomposition reaction with PbNO3 twice lead nitrate as example. Activity 7. About chemical decomposition reaction with H2O water as example. Activity 8. About chemical decomposition reaction with AgPr silver bromide as example. Displacement reactions explanation in activity 9 and 10. Activity 11 and 12 explanation about double displacement reactions. Oxidation and reduction reactions and effects in daily life. Rancidity. Activity 1. Take about 1 gram of quicklime calcium oxide in a beaker. Add 10 ml of water to this. Touch the beaker with your finger. What do you notice? You'll notice that the beaker is hot when you touch with your finger. The reason is the calcium oxide CaO quicklime reacts with water and releases heat energy since solubility decreases on increase of temperature. CaO plus H2O gives rise to CaOH twice plus heat energy. What is the nature of the solution? When this white calcium oxide dissolves in water, produces colorless solution. If we want to find nature of the solution, better to go for test the solution with litmus paper. We know that if the solution is acidic in nature, the litmus paper converts red litmus to blue litmus. Activity 2. Take about 100 ml of water in a beaker and dissolve a small quantity of sodium sulfate, Na2SO4. Take about 100 ml of water in another beaker and dissolve a small quantity of barium chloride, BaCl2, and observe the colors of the solutions obtained. What is the color of these solutions? Can you name the solutions obtained? Add the solution that obtained into beaker and observe changes. Did you observe any change on mixing these solutions? In this activity, when sodium sulfate Na2SO4 is dissolved in water, the solution produced is colorless called aqueous solution. Similarly, when barium chloride is dissolved in water, produces colorless solution also called aqueous solution. When such aqueous solutions of two compounds react by exchanging their radicals such that one of the products formed is insoluble, salt and appears in the form of precipitate like the reaction is called precipitation reaction. Na2SO4 plus BaCl2 gives rise to 2NaCl plus BaSO4. Sodium sulfate plus barium chloride gives rise to salt and barium sulfate precipitate. Examples: Na2CO3 plus CuSO4 gives rise to Na2SO4 plus CuCO3. Example 2. 2Ki potassium iodide plus PbNO3 twice lead nitrate gives rise to 2KNO3 potassium nitrate plus Pbi2 lead iodine precipitate.